Case number 30. Let's check or verify this given identity. We have cosine x over secant x minus tangent x is equal to 1 plus sine x. We are going to manipulate the left-hand side and apply necessary operations and probably equivalence for secant x and tangent x in order for us to arrive to an identity or an expression which is the same as the right-hand side. But if there are some cases that we cannot arrive into the same expression on the right-hand side, we can manipulate the right-hand side as well. But here, since it's already in simpler form, because sine x is already a simpler form, we could apply another algebraic processes in order for us to arrive at an identity. Let's start here by manipulating your secant and tangent x. Of course, our numerator is still cosine x. It's already simple. Let's stay as that. Secant x is 1 over cosine x, because secant x is the reciprocal of cosine x, minus your tangent x is sine x over cosine x. Okay, so these are the equivalence for secant x minus tangent x. Since we have here a difference of two rational expressions on our denominator, let's combine them. And since the denominator is just the same, cosine x, you have here cosine x and cosine x, we can combine them with ease. We have here cosine x, and we have here 1 minus sine x here as well. Now with this, probably we're looking for 1 plus sine x, but we have here 1 minus sine x, and the cosine x and cosine x are just very simple. So that's an indication that we could look for another algebraic process that will allow us to come up with identity. But first, this is a term, and we have here a rational expression. We can rewrite cosine x as cosine x over 1. So we could come up here with the keep change flip method. The keep change flip method allows us to retain our numerator. By the way, we are using here the keep change flip method because our denominator is a rational expression. Okay, so we also interpreted or transformed our numerator as a rational expression of over 1. So we kept it. Change means we're going to change the operation instead of division to multiplication, and we're going to flip our denominator, our second rational expression, our divisor. So flipping that, we have 1 minus sine x here. Okay, when you multiply that, of course, numerator to numerator, denominator to denominator, cosine x times cosine x, we have cosine squared x over, we have 1 minus sine x. Again, this is not the same as our target. Our target is just 1 plus sine x. At this time, we're going to apply the idea of proportion. Of course, let's place this as our final form here. Our original equation will be transformed to this. Cosine squared x over 1 minus sine x. This is equal to our original right-hand side, 1 plus sine x. Okay, so this is only true if we could establish here a proportion. If we're going to come up here with over 1, we have now two rational expressions. They behave like fractions. The fundamental law of proportion tells us that even if they do not necessarily look the same, this is true if the product of the means is equal to the product of the extremes. The extremes are this one here, this term and this term. We're going to multiply that. And the means are these terms here. We're going to multiply that as well. Or, in simpler language, we are going to cross multiply. If the products are equal, then this proportion are equal, or these two forms a proportion. Hence, we have established an identity. So we're going to multiply that. 1 times cosine squared x is just cosine squared x. On the other side, we have 1 plus sine x times 1 minus sine x. If we're going to multiply this side here, of course, this is still cosine squared x. We are multiplying binomial expressions of the same first term, of the same second term, but they only differ on the sign here. So that's difference of two squares. That's special product. 1 squared, you will have minus, and you have sine squared x. You might want to verify if that is really correct. 1 times 1 is 1. Sine x times 1 is positive sine x. 1 times negative sine x is negative sine x. We have positive sine x earlier. Negative sine x is 0. Then sine x minus negative sine x is negative sine squared x. Is this an identity? Now, if you're not yet convinced, go back to this Pythagorean identity here. We have the Pythagorean identity. We have 3 Pythagorean identities, but this is the most common Pythagorean identity. We have the sum of sine squared x and cosine squared x is equal to 1. This is actually derived from the unit circle. Okay? Now, if we're going to subtract sine x both sides or move this on the other side, we'll have here cosine squared x is equal to 1 minus sine squared x. Okay? So we have subtracted both sides. Look at this identity here. This is the same as this. Or if you would like to, 1 minus sine squared x is just cosine squared x. So you will arrive at this equality. Cosine squared x is equal to cosine squared x. We have equivalent sides. This means these two form a proportion, and since this is the equivalent of the original left hand side, and this is also the original right hand side, we have established using the fundamental law of proportion, this Pythagorean identity, and this transformation here, that our given for this case is an identity. This case for missing identity is now closed. If you may, to be ready for some new cases, subscribe now.